At the end of this event, we will have a raffle with a wheel of names where we will randomly choose some lucky winners and we'll distribute very cool prizes. And here we go, right, Linda? Thank you. Here we go to the sponsors. Does anyone want to quickly go through the sponsors and mention them?
Linda?
Yeah, I can. So today for the raffle, we have 5 books from O'Reilly, and all attendees will get the 30 days full access to their online learning platform. JetBrains offers free annual subscriptions to their software. Dan Sullivan will provide access to all attendees to the Google Cloud Associate Engineer Certification Practice Exam. ROI Training offers 4 on-demand Google Cloud certification trainings for ACE and for PCE, which is a value of $500 each. And the independent Google Cloud community, C2C, will offer apparel, as Karen says.
Yeah, great. Thank you. Let's go to the next slide. And I see already Dan joined us, one of our amazing speakers. Hi, Dan. How are you doing?
Hi, Dan. You are muted. Dan, you are muted.
And Kudz as well. He is with us too.
Hey,
Yeah.
good morning.
Oh, yeah.
All right. After all this year, I think I'd be better at managing the mute button. But...
We have our speakers with us, so we are in good hands. Hi, Kudz.
Yeah.
Great. Well,
Hi,
I can
Kudz.
just
Hi, Kudz.
welcome and hello to
Hey,
our
guys.
speakers.
Yeah.
We can go through these slides pretty quickly, but we've had some people join in the last couple of minutes. For more information, I imagine we'll share the slides or the links, and some people asked in the chat. C2C, as I mentioned, if you're interested in Google Cloud, which you probably are given today's content and topics and conversations, we want to be a home for you to be able to connect with other customers and experts and professionals. So what you can expect from us is we have a new community platform we launched last week, where you can have ongoing discussions. We have some various groups on different topics and for different regions. You'll see events and education from us. It's geared towards North America time zone. So those of you from Canada or North America, it's there, but we're doing everything we can to hold things early in the day when we can on the North American side to be optimized for those in other parts of the world as well, and have great participation from all over Europe and all over the world really so far. And over time, we're developing programs along with Google, even though we're independent, for product feedback and to help give them recommendations on what the community wants to see. So our goal, as I mentioned earlier, is our mission there is to unite anyone who's working with Google Cloud across the world. So partnering on events like this with Cloud Study Network and Serverless Toronto is really great for us. You can, as I mentioned, the people you need to know, Jeff, our general manager, was mentioned a couple times, but Ilias, who just popped up at least on my screen, he's our community manager for EMEA and is going to be helping us develop some local regional communities for conversations, both online and eventually in person. So reach out to Ilias, connect with him on LinkedIn or here in the chat. Or the best way is if you sign up for our community, he's all over that. You'll be able to find him there. So yeah, if you want to hop to the next slide, we can wrap up. And I think we're time to get into things. But the stuff I mentioned, a community platform, the ability to connect in events like these, and eventually we're going to build out great regional networks in different countries and in different cities and things like that. So we're very excited about what we're building there. And everybody is welcome. We hope you will join us there. A lot more information on our website. I'll drop the links in the chat. And as mentioned, we're going to raffle off in the wheel of names at the end of the session. One person will get a C2C hoodie. And then of everybody else who joins our community, we're going to raffle off an additional 4 C2C hoodies to welcome you into the community. So, and then if you get involved, it's really easy to get a hoodie too. Daniel's been involved with us for a while. Karen, so they're on our list of people to send some hoodies to as well. We want you to come be involved with us, get active on our community platform, help us plan cool events, and partner with organizations like this. So hello and welcome to everyone we're excited about today.
Great. Thank you, Danny. Yeah, a couple of words about the agenda. We are still in the connect and network phase, which we have to leave really soon. And then we will go to the first talk by Dan Sullivan, which is called How to Design a Modern Data Warehouse in BigQuery, or Why I Need to Forget Everything I Learned in Data Modeling School. So very intriguing title. Our second talk will start afterwards and will be done by Kudz Murefu with the topic Small Teams, Big Things with Firebase and GCP Serverless Services. And we will finish with raffle, as we mentioned before. Yeah, that's pretty much it to our agenda today. Yeah, then I think we can go into your talk now. If you could quickly introduce yourself, say a couple of words about yourself, what's your experience, your overwhelming experience, I should say. But I will let you introduce yourself. You'll do it the best.
Sure. Thanks, Karen. Yeah, my name is Dan Sullivan, and I am a principal engineer with Peak 6 Technologies. And most of my career has been spent in the data world, and in the last 10 or 15 years in the data and cloud world. So I really enjoy working with Google Cloud. Got the chance to work on some study guides for the certification exams in the areas I'm most interested in, which is engineering, architecture, and data engineering. And yeah, I'm looking forward to talking about data modeling in BigQuery. I think it's one of the, sort of the leading tools on the Google platform. And with, hope everybody gets a chance to use it.
I will stop on sharing my screen so you can take over, Dan.
Okay. And let's see. Right. And I'll present entire screen. It'll just take a minute here. Okay. That should be okay. And share. Oh, sorry, I'm having trouble with sharing here for a second.
Hope you're not on Brave browser.
Yeah.
I'm in the Brave browser. Yeah. You know what? I think let's see. I'll see if I can get this actually functioning here. One thing I didn't test.
Try to open a new tab with the meeting and do only present instead of join the meeting.
Okay, yeah, actually I'll have to quit Brave and come back in, so I will drop off and right back.
Okay.
Brave is no good. We have problems with that. So guys, it is good for safety, but don't use it for public meetups. Use it for the sites you don't want your wife to know to you're going.
You are mean. You are mean. Maybe we can show what we have for the raffle quickly. Meantime.
Yeah, absolutely.
Since we are still here waiting. Not
or
sure
if you will be sharing the screen, then maybe Dan cannot share it when he joins.
No, he's here.
He is here. Okay, perfect.
Okay, great.
I will unshare mine.
Yeah.
Dan, you are muted, only so you know. I'm not sure.
Okay, I just wanted to double check and make sure you can see my screen. We're good. Okay, we'll get this started here. Yeah, so what we're going to talk about today is about designing data warehouses in BigQuery and why it's different from the way we used to design data warehouses like 20 years ago. And especially what I want to focus on is what is it about BigQuery that makes it so different, that makes it high performant and makes it very fast and makes it very efficient, but it also requires us to change a little bit about how we think about how we design data warehouses. So first thing I just want to point out that this is an architecture discussion, so there won't be a lot of like visuals of, screenshots from the BigQuery interface or command lines, with details about how to execute a particular operation. Instead, it's more about how is BigQuery put together, like what are its components that influence how we make decisions about how we design our data model. So just at a high level, I just want to point out there are three broad areas of data store options. The first is relational, and those are databases that have been around the longest. They're highly structured. We often use them for transaction processing systems. While they work really well in many cases, they can be difficult to scale. Now, NoSQL databases emerged, in the last couple of decades in response to that difficulty around scaling relational databases. And NoSQL works really well with semi-structured data, especially in applications where when you're replicating data, the replicated data doesn't have to be immediately consistent. And then also the third type is an analytical database. And that's really designed for structured database like relational, but it's also designed to be highly scalable. And what we give up is some of the transactional capabilities. And BigQuery is an analytical database. And so what we're going to do is dig into a little bit about how that's different from what has typically been the case with data warehouses. So early on, so sort of like the early data warehouses were typically designed for relational databases, and we had usually one server, maybe a small cluster like an Oracle cluster. But the key thing was that the storage and the compute resources were tightly coupled. So if you wanted to scale up storage, you were also scaling up your compute resources and vice versa. Typically, when the data warehouse got too big or performance got too slow, we would have to scale vertically, which means we just need a bigger server, more memory, more disk space. And also, these data warehouses, we typically use the same software we use for OLTP systems. So, we might be using Oracle for an online transaction processing system, and we might use the same version of the software to build a data warehouse. And we might change some configurations. We might change block sizes and things like that to have larger block sizes in the data warehouse. But essentially, we're working with the same engine. So it wasn't really optimized for analytical operations. We were taking the tool that was optimized for OLTP and using it for analytical operations. Now, BigQuery is different now in the sense that it's a serverless data warehouse designed right from the beginning to be petabyte scale. So immediately right out of the box, we can start to begin to understand why BigQuery had to be designed differently. Now, BigQuery does use SQL, but it's not a relational database. It's an analytical database. So that means it's really designed for these analytic workloads that are sort of read intensive and don't require transaction processing. Now, there's some other features of BigQuery that are really interesting and make it really appealing. I won't get into these today, but I just want to point them out. BigQuery has BigQuery ML, which allows you to do machine learning directly in BigQuery. You don't have to export the data or go use Python or Spark or anything. You can work with your data right in the database and use SQL commands to implement machine learning. BigQuery now has a BI engine, which is like essentially an in-memory OLAP queue, which makes you allows you to do very low latency operations on large amounts of data. And there's BigQuery GIS if you are interested in geographical systems. Okay, so really under the hood, what's so different about BigQuery? Well, it all comes down to the architecture. And this is probably one of my favorite images that Google has provided about BigQuery. I think it really succinctly captures what's going on here. The key takeaway here is like over on the left, we have our storage system, and over on the right, we have our compute system. And they really are two separate things. In fact, these were developed separately. There's Colossus, which is the successor of the Google file system. This is the global data store, like block storage, data storage system that Google uses. And it's used by multiple systems. BigTable uses it, Spanner uses it. So Colossus is essentially, if you want to write data to a highly reliable persistent storage, it goes to Colossus. Now, typically we think, oh, well, that sounds like network attack storage. You're going to get really long latencies if we're going from a server over the network to grab data. But Google solved that problem by creating these proprietary networking switches that they call Jupyter. It's the Jupyter project, or Jupyter switches. And it's a petabit network. So it has very high throughput. And that means that basically you can go across the network and get the same kind of latencies you would typically get from a server that you might have on-prem that has a direct attached storage. Now, on the compute side, there's really two important components. There's Dremel, and Dremel is a software system which manages a cluster of servers and is responsible for executing SQL queries. So Dremel's really the thing that creates a job that is then executed and managed by Borg. And Borg is the predecessor of Kubernetes, so it's like a job scheduler, and it manages the resources. Now, because BigQuery is multi-tenant, you and I and a bunch of other people all want access to the same resources. Borg and Dremel manage those. Borg manages sort of the SQL jobs, and then there's also the process of managing some of the resources so that they're fairly allocated, and that's something that comes with Dremel. So let's look at each of these components and kind of dig down a little bit, because they all really influence why we do things in BigQuery the way we do. So again, as I said, Dremel's a multi-tenant cluster. So there's no isolating, large volume customers in one physical cluster and others. No, we're all in the same multi-tenant BigQuery pool of resources. Now, Dremel, as I mentioned, maps SQL queries into execution trees. And execution trees is just a name for splitting up a SQL query into a bunch of jobs that can then be executed in a way that produces the required results. Now, these trees, of course, have leaves, and the leaves of the execution trees are called slots. And slots are the compute resources that read data and perform basic computation. So you can think of slots as like a processor and some memory, but basically it's a computation unit that can do the work and has network access and things like that. Now, the inner nodes in the tree perform aggregation. So as you're doing some low-level processing, say you're grabbing a bunch of rows, you're selecting, you're grabbing a bunch of data across multiple rows. You might pick, say, a particular column, and you might need to transform that column or do a calculation on it. That kind of thing is done at the slot level, at the leaf node. Then if you need to aggregate that and, say, combine it with the results that other slots are producing, that work is performed in the inner nodes. Dremel can dynamically allocate slots to queries. And so that's why you can allow fairness, or basically, you don't have the kind of effects you might see like in virtual machines where you have multiple hosts, multiple VMs, and you have the noisy neighbor problem where you might have, one machine trying to consume too much. So Dremel is designed right from the beginning to maintain fairness. Now, that doesn't mean everybody gets the same number of slots. It all depends based on what's available and what's required. Single users can get many slots if that's what they need, but then get few slots if few slots will do the job. But here's another visualization that shows sort of a drill down into the Dremel Borg architecture. What you'll notice at the bottom is we have Colossus. And again, Colossus is the global file system and data storage system. And it depends on the Jupyter network and the Jupyter switches to move data between Dremel and Colossus. Now, within Dremel, we have the leaf nodes at the bottom, so those are the slots that do the computation. And when we're moving data between, say, the leaf nodes and the mixers, those inner nodes, and the root server, and the root server is the thing that basically builds the query plan, the SQL plan, the execution tree. When moving data between those nodes, we're also depending on Jupyter as well. So we have very low latency between all of the servers, regardless of what kind of work they're doing. And then around Dremel, you'll notice over to the left, we mentioned the Borg. And again, Borg is sort of is basically like a job scheduler at this point, and it's trying to figure out how to make sure all of these nodes are being used efficiently. Now, Colossus, as I mentioned, is a distributed storage system. And this is really handy because basically it manages so many sort of storage management functions, things like replication and recovery. We don't need to worry about failover servers and hot standbys and things like that that used to like take up a lot of mental energy and a lot of DBA time to kind of figure out. And also, we don't even need to think about storage systems. You know, when I used to work on like Oracle and stuff, we constantly thinking of, you know, what do we have available? What's our growth rate? What do we think we're going to need? How soon do we need to order disks so that we have enough? We don't need to deal with any of that stuff anymore. It's basically, we just assume that there's enough storage out there for our petabyte scale database. Now, Jupyter, again, global networking switch, and it's petabit scale. That's the critical thing. And it's both for storage to compute communication, but also compute to compute. And one of the nice things about this is that Google, like Google BigQuery, doesn't need to have rack awareness. And what that means is if you've worked with other distributed computing systems like Spark, you might have come across this idea that jobs try to be scheduled, or the scheduler will try and schedule jobs in a way so that as the job is broken down and distributed across multiple servers, those servers are all in the same rack, because within rack communication is much faster than going from between racks. But in the case with the Jupyter network, it doesn't make any difference where it is. You still have petabit scale networking between them, so you have low latency, so you don't have to kind of have that extra overhead of trying to think about rack-based efficiency optimizations, because it's just not needed. And then Borg, again, really the key thing about Borg is it was the predecessor of Kubernetes, and it just manages the mixers and the slots. Now, another component that wasn't in the diagram, but I think is just as important, is capacitor. And that's a column storage format. It's not part of the architecture, but it's the way we use the architecture. And it's designed to support semi-structured data. Now, the critical things about capacitor is that it's built from the ground up to support nested structures. So you can think, if you're thinking of terms of like JSON or hierarchies, it's designed right off the bat to support that. And it can also support arrays or repeated fields. And as an optimization, if you're thinking, oh, nested structures, you have to like maintain the whole nested tree and be able to walk down the tree to get to a particular node, say deep in the hierarchy. That's not the case with capacitor. It's optimized. It has certain levels, metadata that tracks about every row, so that it's very efficient to get to attributes that are lower down in the nested structure. So there's no need to read the entire parent column to produce a nested structure attribute. And capacitor also has specialized compression that make it very efficient to store data. And capacitors, again, it's a columnar storage format, which works really well with analytical databases, because typically we might have very wide tables. We have a lot of columns, but when we query, we're often picking a small subset of those queries. So it's very efficient to say, get all of the columns from many rows versus getting all the columns from a few rows. So capacitor is really designed specifically for this kind of analytical application. All right, so this is all well and good. So now we have a sort of a peek under the hood of what's going on in the Google data centers. But what does this mean for us when we're building a data model? So I would just say, I'll go to the punchline right now, and I'll sort of give it all right now, and then we'll drill into the details. So first thing to remember, so this is a distributed system, so things are happening in parallel. And the things, at the end of the day, databases are very good at scanning data blocks, looking for pieces of data. And BigQuery is like that as well. In fact, it's so good at scanning that it doesn't even have indexes. Right, so there are no indexes, which is a sort of a staple of data warehousing when you're using a relational database management system. So what we want to remember is everything we're doing is, from a design perspective, is driven by the knowledge that BigQuery is basically a big scanner, and it's scanning through our data. Oh, and the other thing to keep in mind is that Google charges for BigQuery based on how much data you scan. So Google has a vested interest in all of us being very efficient and using the Google resources efficiently, and they incentivize us to do that as well by charging for how much data we scan. Also, so then the question is, well, how do we reduce the amount of data we scan? Well, partitioning is a big one. Partitioning basically breaks up big tables into smaller tables, and it allows us to minimize the amount of data we're scanning to answer a particular query. Now, BigQuery has something known as clustered tables or clustered partitions, and basically that's another way of reducing scanning. And the way we reduce scanning is by keeping the data in some kind of order within that partition. So we can take advantage of the fact that the partition is always kept in sort order. Now, BigQuery supports joins, and it's not a problem to do joins, but it can require shuffling across slots. So another thing that we can do that can make things a little more efficient is to actually denormalize and take advantage of capacitor by using nested and repeated fields. So these are sort of the data modeling techniques that go against the grain of many things that you might have practiced when designing for OLTP, or even for denormalized data warehouses when using a relational database management system. But these are sort of best practices, good patterns to use when designing for BigQuery, because BigQuery is built differently from other databases. So we don't want to carry over practices and patterns that we use that were sort of optimized for one type of system in one architecture and bring it over to another architecture where it's not a great fit. So the idea behind partitioning, as I mentioned, is just making a big table feel smaller. And here we have 5 partitions. Now, those partitions all have like some range of values that they take care of. So partition A might be, 1 to 100. Excuse me. Partition B might be the, 100 to 200 and so on. Excuse me. And so with partitioning, we're able to specify in our where clause, oh, I'm looking for range, 310 to 320. Well, then we know immediately we only need to scan partition C. And if it's clustered, if it's ordered, we can even reduce it further. But the idea here is, again, we're just basically breaking up a big table into ordered chunks, and we know what the order is, and we can use that to optimize our queries. Now, so again, partition tables are just tables that are grouped into partitions, and it improves query performance because we're reducing the amount of data that's scanned. Now, there are a few different ways to partition a table. We can partition by ingestion time. And so what happens is, as we're loading data in, it's loaded into a daily date-based partition. And what's really nice about this is BigQuery automatically creates the new partitions for us every day. And it uses the ingestion time to determine which partition things go in. Now, it also creates a pseudo column called _partition time. So that's like an extra column in the table that we can use in our queries to determine which range or which sets of partitions we want to be scanning. Now, the partition time is a date-based timestamps, and we actually specified in the where clause, we can say where _partition time something, some condition. Excuse me. Now, there's also date timestamp partitioning. And this is similar to ingestion time in that it's based on a date or timestamp column. And each partition holds 1 day of data, but there's no need for a partition time column because we use one of the columns that already exists in the table. Now, there are a couple of special partitions that are created. There's the null or _null_ partition, and that's where rows will go if they don't have a date in that particular column. Or if the value in the datetime column is outside the allowed range, then it'll go into this unpartitioned partition as well. And then the final type is called integer range partitioning. And this is just based on some type where we have an integer column. Now, it can't be a repeated field. It can't be an array of integers. It needs to be a scalar, so not a repeatable. Now, BigQuery has something called legacy SQL, which is an older SQL that was used with BigQuery originally, as opposed to standard SQL, which is what we use now. Integer range partition can't be used with that older legacy SQL, but I can't think of a reason why we wouldn't be using standard partitioning on a new data warehouse now, excuse me, standard SQL on a new partition now, so this probably shouldn't be really much of an issue. Now, in other database management systems, you might have come across this idea of sharding. And sharding is the idea of using, say, a separate table for each partition. So, for example, have a separate table for each day. And you might name that table with some prefix like, sales orders, and then a particular date. And then you just have a bunch of these sales order tables. And then you use a union to query or scan multiple tables. And that is one way of doing it. But in BigQuery, partitioning is preferred over sharding because there's less metadata to maintain. So each of the tables in the sharding scenario have its own set of metadata. And there's also access control issues. So if there are fewer tables, then there are fewer times you need to basically check access controls and to determine, does a particular process or query or service that's trying to query the table actually have access to that particular table. So as a result, partitioning gives better performance than sharding. So definitely, in most cases, we want to prefer partitioning over sharding. Another thing we can do is set something called the require partitioning parameter. And what that means is that at a table, or even at a partition level, we can require that the partition column be used in the where clause. Now, this is useful if other people are querying your data and they might not know about partitioning and might not understand the implications of, say, doing a full table scan over a petabyte table and what that means in terms of performance and cost. So this is a way of basically at least putting guardrails on how much data somebody can pull back. Certainly, they could have a where clause that goes from the earliest date to the latest date, and you end up still partitioning scanning a lot of data. But at least the where clause gives you a mechanism to force people running queries to put some limits on the range of data that's being scanned. Now, I mentioned clustered tables earlier, and in a clustered table, the data is sorted based on values in one or more columns. And this can improve performance like with aggregate queries. So if you know like the sub-range where you want to say do a sum across some range and it's already clustered, it's pretty easy to find that. And it can also reduce the scanning when the cluster column is used in a where clause. So if you know, for example, if you're in a partition with values between 300 and 399 and you're looking for say 310 to 320, and if you know, as soon as you hit 321, you can stop scanning. You're never going to see another value in the range of 310 to 320 in that clustered table. So that's why clustered tables can further improve this idea of reducing the amount of data that's scanned. Now, partitions are like anything else in the universe. They're subject to entropy. So things start to get out of order. Especially as new data is ordered, it doesn't necessarily come in order. So as you ingest the data, you might need to reorder things. And that's okay because BigQuery automatically reclusters in the background. So we don't need to worry about that. This is just, again, another one of those like services that you might have had to think about earlier. Like if you used to use like materialized views and when do we need to refresh and things like that. Or, how do you manage storage? You don't need to think about managing storage. You don't need to think about resorting your clustered partitions, because BigQuery just takes care of that for you. Now, the final sort of architectural piece that is different about BigQuery is the ability to use nested and repeated fields. Now, you can use nested and repeated fields in other databases, like Postgres will support nested structures like JSON and XML, and you can have arrays in Postgres. But it's not designed, like the storage structure isn't designed like Capacitor to be optimized to store that kind of data the way BigQuery is. So here, for example, is a screenshot of a part of the BigQuery console, and I'm looking at some data sets, and I've opened up here on the left kind of column a public data set called Bitcoin blockchain, and I've highlighted the transaction table. And if you look at the transaction table, you notice it has attributes like timestamp and transaction ID, and both of those, one is an integer, one is a string, and then it has something called inputs, and that's a record. So its data type is record, and its mode is repeatable. So the repeated simply means we can have an array of these things. So we can have an array of these inputs, and let's take a closer look at those inputs. So inputs to this Bitcoin transaction have things like script bytes and script string and a number of other things. I'm not familiar enough with Bitcoin transactions to really understand what these things are, but I can tell that this is, from a relational data modeling perspective, this screams, oh, I need to create a separate table and use a foreign key from transaction to this other table where I will have transaction inputs, and each of these will be its own row. But with BigQuery, we don't need to do that. We can actually store this data together with the transaction inputs with the transaction data. And because we can take advantage of Capacitor and its ability to store recorded and repeated fields in an optimal way. So this is why we don't need to denormalize, or one of the reasons we don't need to denormalize, or at least we don't pay a penalty for denormalizing. And in fact, it can be advantageous to denormalize because this is a more efficient way of storing this kind of data. And what I mean by that is, like when transaction and transaction detail or transaction inputs, it's like if you're using a particular transaction, you're almost certainly going to be using some of the data in the inputs, and you would have to go and do a join, but you don't have to do that. That data is relatively easily accessible. So that kind of covers the key points I wanted to make. So I just wanted to reemphasize, when we're working with BigTable, we just are constantly thinking about how do I deal with scanning? I know the basic operation is scanning. So I can use partitioning to minimize the amount of scanning. I can use clustering within a partition to further reduce the amount of scanning. Now I can use joins, and that's perfectly fine to use joins, especially joining large tables and small tables. That's certainly fine. But it often helps to denormalize and use nested and repeated fields to avoid joining, especially when you're joining large tables, like two large tables. If you can find a way to denormalize and use nested and repeated fields instead, that's almost always a better option. So that wraps up my talk. So I will stop sharing, close out, get back to the meeting. And Linda, I can turn it back over to you, or Karen.
Yeah, thank you.
Thanks.
Dan, very much. I have to watch it again in the recording because there are so many new concepts to me that I was quite overwhelmed. But it's a very nice insight into data warehousing, and everyone, we can take some questions. If you want to ask a question related to this talk, you can post it into the chat.
Can I start?
Yeah.
Dan, first I want to thank you. I think most of the stuff I learned about Google is from your books and courses. So I owe you big time.
Thank you.
So now on the practical side of the BigQuery, so this was a more business kind of question, like looking back at other clouds, and we were chatting about that before. I'm not going to pick on anybody, but it seems to me that lots of AWS users are picking Snowflake instead of cloud native tools. And you mentioned that you can speak up to compare BigQuery and Snowflakes. So just like how they're similar, how they're different, because it seems to me that they are true competitors, that there is nothing else that stands up to BigQuery right now.
Yeah, I think, yes, definitely. Snowflake also follows this idea of decoupling storage and compute resources, which is really important in AWS. I believe Snowflake really got started in AWS and kind of in response to Redshift, where you'd have to vertically scale, or your Redshift cluster, and the storage and compute was tightly coupled. So they developed ways of using AWS resources to have independent storage, independent compute, and manage them separately.
Mm-hmm.
So in that way, it's like, it's probably, so Snowflake is probably closer to BigQuery Omni, which basically allows BigQuery to run in other platforms, other clouds. But the critical thing is with BigQuery, it's not just the decoupling, it's like the Jupyter Petabit network, the Colossus file system, the scalability, the rapid scalability. We're taking advantage of a lot of what Google built for its search engine and other services. And those things, those optimizations, like somebody pointed out in the chat, that Jupyter is like a key differentiator over the competition, and I totally agree with that comment. I think they're absolutely right. So Snowflake is definitely great. I mean, they're just growing by leaps and bounds, so they're doing well. So I think they are much better in a lot of ways for a lot of use cases than, say, Redshift or using Postgres or Oracle. I think it doesn't have the hardware network infrastructure advantages that BigQuery has, because when it's running in the Google infrastructure.
Okay. So takeaway from me to recap for the people, because we were all overwhelmed with information shared. I think the highlight is here a petabit networking speed. So you don't have to bring your data close to your compute. It can be anywhere.
Yes, exactly. Yep.
Okay, so that's the differentiator. Thank you so much. Thank you so much. Anybody else?
Yeah, we have
there is a question in chat.
Yes, yep, I will provide. What is the best approach to remodel and ingest Snowflake legacy data? Let's see. So the question is, what is the best approach to remodel and ingest Snowflake legacy data? So using like dimension, fact tables, star schema. Also, any experience modeling and ingesting Salesforce data source? Actually, Google has a document on best practices for data modeling in BigQuery, and they actually recommend that you just bring over your star schema or your Snowflake legacy model and implement it directly in BigQuery, and then just basically test the performance, see how it is, and if it's working well, great, and if not, just kind of optimize as you go. Like figure out what the weak spots are. So that's their recommendation. And I'm glad I read that recommendation, because I used to think, oh no, I would immediately just rebuild from scratch. And I immediately start using nested and repeated fields and things like that. And they know much more about BigQuery than I will ever know. So if they say this is considered the best practice, then they must have seen from multiple engagements with clients that you still get really good performance, and it's low cost to bring over a star schema. So that's probably the best way to start. So in regards to Salesforce, I'm sorry, I don't really have any experience with Salesforce. I can't speak to that too much.
Then if you can, I was Googling for that article. There is so much on the best practices. When you can, during the later speech, maybe you can paste it in the chat, and I will share all the links from the chat with the crowd.
So there was questions about the slides. We will share after the meeting. We will send an email contacting all the attendees, and you will receive the link. So don't worry, or today or tomorrow you will receive the slides, and we will have the link for the recording. Daniel will provide us. When we have all the information, we will follow up with an email for everyone to get all the information.
And keep sharing the links in the chat. I will share those as well. So you will notice in most of our meetups, when you scroll on the video, there are all the links that people mentioned if they were relevant.
Okay, great. And I'll add some links for papers to like the Google engineers that design Dremel, capacitor, and others I can find. And Linda, I actually did some updates after I sent you a copy of my slides, so I'll send you the latest version as well.
Oh, thank you.
Let's see, there's a question. Do we need another GCP service in order to schedule or orchestrate our BigQuery codes? No, you can schedule jobs within BigQuery. So that's really nice. Again, there's definitely scheduling services, but you can do that in BigQuery as well. And let's see, I don't see any other questions. I will say I'm about to begin to work on a course on BigQuery that I'm going to be putting out on a new platform called LeanPub. And it's one of those you can it's like reading the book as it's being written as I write it. So I will send Linda and Daniel and Karen a link to that as soon as I start it. And I will start it out as free access. So you can go and grab that if you're interested in BigQuery.
Lovely. That's LeanPub. You're going to do that.
Yeah, I'm going to do that on LeanPub. This is my first time on LeanPub.
That's lovely.
There is another question for you, Dan.
Oh, okay. Oh,
Hi, Dan.
Column storage for analytics. Oh, great question.
You mentioned.
Oh, I'm sorry. Yeah, I mentioned BigQuery as columnar storage for analytic operations. What is it about BigQuery that differentiates from BigTable? Well, first of all, BigTable is a NoSQL database, and it's sort of the species of NoSQL is a wide column database. So it's basically, its data model is a sparsely populated wide table. It's really like a multi-dimensional matrix, but it's considered to be very sparse. And so when you're storing data in BigTable, what you're optimizing for is a minimal amount of storage for like a sparse array. And so BigTable stores using protobufs, which is if you've used like protobufs for like message passing, it's that kind of structure that gets used in BigTable, whereas in BigQuery, it uses the capacitor format. And so BigTable is really good when you want low latency writes to a database, and you're really limited in how you're querying it. So there's no joins, there's nothing like that. You're either looking up by your key, or you're looking up by a range of keys. That's really all you can do with BigTable. So with BigTable, you model based on how you're going to query the data. So you might have a bunch of tables that actually replicate data, but they're ordered in different ways so that you can efficiently get to the data depending on your query. So, but yeah, and it's all stored in Colossus.
Now, you reminded me. Can I throw one quick question?
Oh yeah, please.
I'm going through your book now, Data Engineering. Thank you again for that. And, there is a federated access to the data storage outside of BigQuery. So when do you draw the line, like a quick and dirty point outside or import to BigQuery?
Yeah, you're probably going to, I think the decision is based on like performance. If it's federated, you're not going to get the advantages of capacitor, but you don't have to load the data. If you're getting decent performance with, say, federated data, and you have a bunch of columns, a bunch of data in cloud storage, and you get good performance using whichever Parquet format, whatever the file format is, then that's great. Maybe that works. And part of it will depend on the life cycle of that data and who needs the management. And sometimes it's easier, like somebody can put the data in there and they don't need access to BigQuery. So a lot of it depends on both performance and life cycle, I would say.
Awesome.
Those would be the considerations.
Thank you so much. And I hope that's not COVID. You keep coughing.
Yeah, bronchitis is kicking in again this year. Let's see, can you please suggest something better than the documentation for BigQuery? There was a book out of O'Reilly a few years ago on BigQuery, and I remember it being like really well written, well structured. I don't know how up to date that is. I have not looked at that in a long time. Yeah, the way I learned BigQuery is from the documentation and just being hands-on. Oh, and I should have mentioned BigQuery, or Google has what they call the BigQuery sandbox, which allows you to work with BigQuery for free. There are limitations on how much data you can query. It's maybe like a terabyte a month of scanning and querying. and maybe there's some storage limits as well. But it's a great way to learn BigQuery. So if you're starting out in BigQuery, I would say have the documentation open in one window and just like bang on the keyboard in another window and start executing queries and play with it.
Quick Labs, I think they have good Quick Labs. Like you can find anything there.
Oh yeah.
And follow Dan on LeanPub and learn from you.
Yeah, and also I would suggest both Coursera. All the Google courses on Coursera are really good. I would recommend those. And if you're on YouTube, go out to YouTube, Cloud Next, or is it Google Next? Cloud Next? I can't remember. The big conference.
Cloud Next.
And just search for BigQuery and those. There are great talks, and there's definitely a really good talk on migrating data warehouses there from like 2 or 3 years ago. So those are also good resources. Let's see. Can you please?
Snowflake versus GCP.
Snowflake and GCP. Oh. Here's a question about more details about BigQuery Omni, and is it available on-prem also? I believe it is available on-prem, but I don't know enough about Omni, so I wouldn't want to say specifically, but I believe it is. I only know as much as I read in the blogs and the press releases right now. I haven't actually worked with it.
So why I liked Omni was because it was built on Anthos. I'm really afraid of the things with great names like Kubernetes. They tend to be complex. So Anthos is a proof that it works because Google used it to bring BigQuery.
Yep, that's a really good point. Yep. Yeah.
Actually, there was a correction. Snowflake or BigQuery versus BigQuery. Which one?
BigQuery with regards to being available on-prem?
No, it's BigQuery versus Snowflake. What you would prefer? And I think the
I would take BigQuery. In AWS, I would take Snowflake over Redshift for sure. Yeah.
Yeah, I think you then mentioned it many times in our talks and your presentations that AWS is a great system itself, but there are some key advantages to Google Cloud which you prefer, and the preference might be different for different professionals. And that's.
I can add something to answer to that question. I just pasted a link in the chat because I had the same dilemma. I'm noticing that people from other clouds tend to go to Snowflake instead of BigQuery. And I will have the meetup next, like in 2 months, with the celebrity of Amazon serverless world. Like his ultimate serverless mindset, Joe Emison. He built like 5 companies serverlessly in 3 years and then decided to go big. Moved to Columbus, started insurance company branch. If you're in the US, check him out. And because it's a business, he just needs reporting. He says, it's easier to do it in BigQuery. So he hired a company, Fivetran, to bring the data from DynamoDB into BigQuery, and he has the business. So he spoke about his Amazon side of business in 2019 in Serverless Conf New York. He's going to come to Serverless Toronto virtually to talk about the part 2, business analytics using BigQuery. It's like kind of bringing 2 religions together. You don't have to choose Snowflake if you're on Amazon.
Oh, right. Yep. I see there's some other questions about how easy it is to get huge amounts of data from external sources to BigQuery. Anytime you're moving a large amount of data, like huge amounts, like terabytes and above, it's difficult. But there is something called the BigQuery transfer service, which allows you to schedule data migrations and things like that, which could be useful. There's also a way to use basically a transfer appliance if you need to move data into cloud storage first. So there are some ways. I would definitely look up cloud storage transfer service and BigQuery transfer service there. Any restrictions when exporting data out of BigQuery? Oh yeah, no, there's no locking. You can push it out in all kinds of formats. You can store things and push it out in standard formats. So it's very easy to get it out and make it accessible elsewhere. Yeah, I agree. Yeah, platform and service GCP always had upper edge. Yeah, I think so. Yeah, that's how I ended up in Google Cloud. I used to work in AWS first, and I found the data services were much better, and that's why I switched over years ago. All right. Well, thank you again, everyone.
Thank you, Dan. Thank you very much.
Thank you, Dan.
Yeah.
We really appreciate being with us today again with our community.
Look
And
forward to joining you again sometime.
We'll keep
Thanks.
learning from you.
Great.
Yeah.
So, and we will begin with the second talk, right, Linda? Yeah. Kudz, are you here?
I'm here.
Hey, cool.
Hi.
Take the mic.
I
All
want
right.
a big intro to Kudz, like, guys.
Yeah.
So Kudz is my friend from Serverless Toronto community. He gave 2 talks over the last 2 years in Serverless Toronto, and I don't want to keep him a secret because Serverless is not about technology. It's about the mindset to get business agility, to deliver things faster. Like when we first met him 2 years ago, it was, oh, I'm not a developer. You know, I just needed a website. And then we start drooling when we see what he built. A year and a half later, he comes again and uses more Google services. So I says, like, this is a perfect talk for you to see the journey from zero to hero and how small teams can achieve huge things. So, and it happens to be serverless and Google technology. So Kudz, thank you for accepting my invite.
No, you're most welcome, Daniel. It's a pleasure.
Thank you.
All
Thank
right. Okay, so can I just take over? Or
you. Yeah, I'm stop sharing it right now. Give me a second.
Wonderful.
I'm handing it over to you.
Okay, I'll just do my entire window. All right. So thank you very much, Dan. Really enjoyed the talk. Once again, I'd like to thank Daniel Zivkovic for inviting me and connecting me with Linda and Karen. It's a pleasure to be able to speak in front of you guys. So yes, so my name is Kudz. My full name is Kudzanai. And I wanted to just come and share my experience in how I leveraged Firebase in order to build my streaming application, my music streaming application. This journey for me started 3 years ago. Actually, let me discuss my background. My background is actually in business. I went to school for business. I majored in international business. I was by no shape a techie. I just had an idea that I wanted to create, and I found myself playing around with some of these tools, and today we are here. So Streama is a music application that I came up with in 2017 whilst I was still in school as a business student. It was just an idea where I had, as an immigrant, I had a tough time trying to find some of the music from back home. You had to visit tens of websites to just, compile like a list of 100 songs. And some of this stuff was not readily available on some of our popular music streaming platforms, at the time at least. So I just said, you know what, it would be a nice idea to start a website or some solution where we can be able to, distribute this music and make it available for other people who are also outside of the country or in the country trying to get access to the latest tracks. So, off we went. I started, the easiest way to start at that point was to, kick off a WordPress blog. All we used to do was just create a little article, add the link of the new song that we found somewhere online. We write about it, then, we post it. But, at the time from 2016, 2017, there was a transition of how people were interacting with music and media, Netflix, Spotify. People didn't have time to be reading articles. If you're going to give me music, give me music. So I also wanted to start making that transition to make an app or a website that was solely about the music. You come in, you search for a song, and you find it. But being on WordPress and not being too very technical, I had to rely on the infrastructure that was there. So you use plugins. But the thing with those plugins, they were not full solutions. If you wanted to implement one, you had one feature in mind, you ended up using like 4 or 5 plugins just to do one thing. Customizing the themes to the point where the site was so bloated. We actually ended up at a point where I probably had more than 60 plugins, and each of these plugins probably bring in 3 to 5 scripts. The site already has its own scripts, maybe 10 scripts. So you can imagine the site's downloading hundreds of scripts, and it was, you used to actually wait, and there'll be a white screen there, and you know, those who were patient enough and really needed the song would wait for us for the page to load. So you know, it became obvious to me that I needed to go and get someone to help me build out this website. Maybe someone who knows WordPress, or a full developer who could just help me rebuild it from the start, because whatever I had done clearly wasn't working properly. But that was a new challenge on its own. You know, at the time, being a student, I only knew other students. I approached a few people who were freelancers, but they quoted me thousands. I didn't even have $1,000 in school, probably $100 or so. So that route was already out of the window. I didn't really know any developers. So I was stuck with that bulky, slow website. And, you know, it became very evident to me, or it's a question that started to come to me. I said, why am I even using this? I'd heard of other solutions, and I was not questioning, should I go somewhere else? Should I use another platform? I tried Wix. That was its own problem altogether. It just didn't work for this problem set that I had. And as I mentioned, these are some of the situations I was having. Heavy reliance on plugins, very slow page loads. And another big issue that started to come up there, because we had uploaded so many songs, we physically had to store those MP3 files that we were uploading to the site. And at the time, we had a hosting service. I believe it was called TSO Hosting. At the time, we were on a package where they had maxed us out at 300 gigs. So we really couldn't upload much anymore. So we had to come up with a new solution of setting up our file storage. And all these problems really were pushing me into a corner where I either had to understand this technical field, or I had to get someone else, a partner, or someone who could help me. So I eventually just had no option but to learn how to code and build it myself. And I did this in silence. I did not tell anybody. None of my friends knew. I just said, you know what, I'm really frustrated about this. I'll learn how to do it, even if it takes me half a year. That's just the path that I have to take. Lo and behold, I was actually able to learn how to code pretty fast. Learned some JavaScript, some HTML, CSS. Within about a month and a half, I think I had enough skills to kind of, you know, break my way in there and build, you know, something somewhat functional. And lucky enough, I managed to understand how React framework worked. So I went with that, and I started building, you know, the basic markup of the website, designing it and everything. But I soon ran into newer issues. I didn't have a database to store my data. I didn't have the hosting. I didn't have a backend, no storage. So now I had to go out there once again to find out, okay, Kudz, what are we going to do about this? Where do we implement some sort of, Apache database? I don't know. All of these solutions I was seeing online were just a little bit above my understanding, because I'd only been coding for a while. So I didn't even know what Apache and all these database things were. So I once again started scouring on YouTube, endless. I think I watched every video, Traversy videos, and then lo and behold, after a couple of weeks of scouring, I bumped into Firebase, which I call the miracle from heaven. And literally, this guy in the picture has a channel on YouTube called The Coding Train. He teaches a bunch of stuff from machine learning all the way to basic JavaScript. And he really helped me. I remember when he was presenting this idea of Firebase and the different options he had for setting up a database, everything he was saying about the service made sense. It was addressing some little problem that I was having with my platform. And I was like, you know what? Even if they can give me 3 solutions of all these problems that I have, you know, that would really help me a lot. So I started reading through their documentation. I read everything. Some of it I didn't understand at the time, but it was, you know, I got to a point where I kind of understood how to get kickstarted, you know, start a database, start pushing some stuff in there. And yeah, that was really the turning point for me. So these are some of the services that I utilized at the beginning. I was using their authentication, the database, the functions. We're really replacing those plugins that we were using, the hosting, self-explanatory, and the storage. So I'll go ahead and I'll just describe these features, how we use them, and how I believe they were helpful for us. So yeah, the real-time databases. If you've used Firebase, you know all this stuff. But the databases are very simple, no SQL. It can be accessed through the web or through your code base. They have an SDK, a web SDK that you can access in your application or in your backend services. And this was very good because I had never built a database. I'd never worked with databases. So you can imagine this is my first time speaking this language. So the web interface was really my way of getting into this. I could click around. I could, the amount of times I deleted my own databases was shocking. I think I did that like 5 times where I delete something by accident, and then I come back and I build it all up again. But it's very simple. Once I kind of grasped the concepts, I was able to now move on to implement it in my code and move on with. As you know, the NoSQL databases is a tree-like structure, so it's very free to actually build out my own data structures. Before I knew what that even meant, I was able to build out exactly what I wanted because the tools were there and they allowed me to do that. And most importantly, there was no need to set up a server. At that point, if you told me that I need to deploy a server, you'd have been speaking Greek or some other language to me. I didn't know about DigitalOcean, deploying to Heroku, and all kinds of things. So this was a perfect scenario, a perfect situation for me, really. And for those who have never used it, this is what it looks like. You have your songs database here, and then you have the children right here with the unique keys. So those unique keys are essentially a row in a table, in an SQL table, and then you have your properties in there. Just looking at it, for me, that made sense. I could understand what's going on there. The documentation was very self-explanatory. So yeah, and as you can see here, they also have real-time syncing, which allows you to essentially do anytime something changes in the database or specific on a specific property or reference. Whenever something changes, you can get notification. You can get those real-time updates. You don't have to refresh your page. So if you add a new object or a new row into a table, you don't have to refresh the page. As long as you're subscribed, the database sends those updates to you, and you can see just the simplicity that I'm referring to here. That's 3 lines. Essentially, you could say that is 1 line of code. You have your database object, you subscribe to it, and you say, hey, when something is added, run this function, and then that's the new thing that's changed. And in my case, that was a song. When I add a new song, or do something, say someone's scrolling through the front page, if there's new music that's been added, it should update that list at the top. There are many use cases that someone could use these in the real world. Maybe you're streaming metrics, you're doing reporting, maybe you have live updates for scores, for sports, or I don't know, maybe even in finance where prices are changing, stock markets, and those kind of things. People can't just be refreshing the page. You could write a few scripts and you could be getting real-time updates, and all your clients will be getting this. So it is a testament of the simplicity of what these guys were able to do. So yeah, I'll just give a quick demo. I will not play around too much, but just so you kind of get an idea of what I'm talking about. So this is the Firebase dashboard. I'll just bring it out here. You have your console here on the left, your authentication, your databases, your file store and real time, your storage, and your hosting. In this case, the real-time databases. There we go. So you see we have an empty database tree right here, you know, and this is what I was doing when I started, right? I'll come in here, I'll enter in a new record, and, you know, boom. Oh, okay, I see what's going on here, you know, and I'll keep playing around with it. You can create more robust data structures. You can add arrays in there. You can add a person, you know, add a name. Yeah, and that's this is the simplicity of it. It looks like a joke in the beginning, but very quickly, this tree could be a person with family members, with siblings. You could have IDs. You could add indexes in there. You can do a lot with that. And that was very powerful. So I did a little demo, little simple application of what that real-time update looks like. So you can see the database right there. I'll just clean it up a little bit. You know, I have a little thing running on my local environment. So just say hello. Boom. It shows up in the database. You can continue to add stuff. And this is simple functionality that when you're thinking about a product, you're not thinking in technical terms. You're just saying, okay, I need something that does this, that does this. And if you delete something, it updates automatically on your UI, just like that. Done. We have not had to write more than 15 lines of code. Can you just confirm if you guys can see my editor right now?
Yes, we can.
Okay, thank you.
Maybe if you can make it a little bit bigger, like Shift+.
Okay, sure. Okay, that's a bit too much.
Perfect.
Yeah. So, you know, you don't really, again, picture this from someone who just started. Yeah, it's a bit frightening at the beginning, but that is simple. You know, I have my database here. I say, listen for new messages. If something is added, render it. If something is deleted, remove it. And, you know, I have the functions of how to do that down here, of course. But it's clean, it's simple, and it's straightforward. And that's what I loved about it. And even the HTML, you know, it's your basic stuff. That's all the HTML that's there. So even if you need to teach someone this, it's not too confusing. And I think that's what it's all about, this platform. You need to be able to get up and running very quickly. Firebase storage, another big issue that we were having. Storing those MP3 files was very key, because if we don't have storage, then that's it, it's done. So it's the same infrastructure that it's built on Google Cloud Storage. It's the same infrastructure that powers Spotify and Google Photos. So it's really very robust. You're able to upload and do downloads. You can use the drag and drop interface, or you can use the code base. And once again, just to show how simple that is as well, in terms of your code base. Where is it? Yeah, there you go. So this is the storage, the Firebase storage here. I already had something in there. We'll just delete that. So it's very instant, it's very simple, and I'll show you what the code looks like. Just upload a picture, wait for it a couple of seconds. Should be done. Oh, I have to upload it. Yeah, my bad. Let's give it a few seconds. And there you go. It's in there. And these are like little building blocks. And as I was doing this, I could already picture what I could build with it. And then you go again and you look at what the code looks like. When I click upload, it hits this upload files function, and that's it. It just grabs the file, boom, pushes it. That you don't need to be that smart to figure some of this stuff out. So again, that's another testament of how simple it was. And that's what I was seeing at that time, at least for me. And that's that web interface. You know, we have our folders, you have your artist profile covers, you have your playlist images, your song artwork, as I showed there. And next, we have hosting. Hosting was very important again, because we were now beginning to, you know, our cost was now tied to the storage. So we're paying a lot of money that I didn't have at the time. My budget was very tight. I wasn't working that much. So I needed something that was simple, had a bit of a free tier so that I could be able to test out my stuff and kind of learn and get to the point where I can start to go and either raise money or get some money to be able to back this thing. But before then, I was not even able to do that, because even in testing, I was paying hundreds of dollars. But now I have this option. It's easy to deploy. Caching, I don't have to worry about caching. It's already deployed to Google's CDN across the world. My users are in Zimbabwe, thousands of miles away. So this is very helpful. I believe they have CDNs in South Africa, which is just a couple of hours away. So, you know, people don't have to wait for 10 years for the page to download, because that was literally the situation. SSL was built in. I don't have to worry about that. Honestly, if I had to worry about SSL at that time, since I was building it on my own, again, I don't know what language that is. I didn't understand that. So all these are tools that are very helpful for me. The next one and the last one is Cloud Functions. These are just the same thing, or pretty similar to Lambda on AWS. You write a little bit of code that does a specific task, and you deploy it, and you can execute it through HTTP. And I already write JavaScript. I kind of understand TypeScript. This is in my ballpark. So I had these little tasks. I want to send some emails. I want to run some metrics. I want to do little jobs that I don't necessarily want to hard code into the website. You know, I just need to quickly write it and upload it, because it might change in the future, or I might combine those little services with something else. So functions were amazing. At that, I remember I probably had like 20 of these running at the same time. Another beautiful thing is that these cloud functions, they work hand in hand with every application that Firebase offers. As you can see on the right here, you can use your functions to react to your authentication, your analytics, your storage, PubSub, and whatnot. And for me, I was using them for the database. Whenever I upload a new object to the database on a specific reference or specific object, I'll tell my function, hey, listen for this. If I upload something here or I delete something, cross-reference it, check what's going on, index it. If I upload an image to storage, in Zimbabwe, data is very expensive, extremely expensive. We're talking people have to buy their storage, $1 a day, and they get 100 megabits. So if that's what people are working with, I cannot afford then. I have to think about in terms of when they load that first homepage, there's going to be a lot of pictures there, high quality images that are a megabyte each or even more. So if I have 100 songs there, that's 100 megabits before they've even played the song. And storage allowed me to upload stuff and then create little thumbnails. So I don't need to write a compression algorithm or compression code. I just create a function that listens, and Google already adds this in. They already have, Firebase already has some of this code base. So you can just copy and paste it, you add it in there, and off we go. We've saved our users' data, and off we go to the next problem. And you can schedule them to run periodically. At the end of the month or every week, I might need a little job that I do where I'm counting something or I'm balancing off my accounting. That's another thing. We're doing our own accounting using QuickBooks. So you have to do your own double entries and all of that stuff. So I have a function that jumps in and does some of that stuff to make sure everything is okay. If there's any errors, we look at them and we reconcile. Yeah, so this is not a demo. This is essentially just showing you what we were able to build with that. That you can actually build a real product on top of this infrastructure. So this is our platform, Streamer. We have our artist corner where our artists are able to upload music right here. And then this is the music player. So as you can see, there's a lot of pictures loading here. So that could really eat up a lot of data for people. So those are compressed if you're using the mobile application. You can search. You can search. You can open playlists. You can play your music. There you go. So, and all this is built off those exact features I just showed you. So you can really build something that's robust. You can do your authentication just like that. And then this is our artist platform. Again, hosted on, uses Firebase all the way. Those metrics, we keep them coming in real time. People are able to come in. And again, think of it in the context of Africa where there hasn't been a solution that's that solid. We're able to actually give people a solution now. You can edit your account, you can come in, you can chat with support. Remember, I was discussing that real-time situation. You know, I can reply to someone and it's instant. So there's that messaging effect. So you see that all those little features, they easily come together to build something that's a bit more robust. So, you know, bringing it all together, if I haven't said it 1,000 times, Firebase is an all-in-one solution for people to go from idea to production, idea to that solution that you've been thinking of. It's not about spending time and years worrying about infrastructure and stressing out. You know, if I can be a business guy and quickly learn how to code and interact with this, then that means everybody can do it. They're way more smarter people than me. So it's a great tool. You know, currently I've kind of moved out of that developing and coding role. We're now kind of getting back to business now. And we now have 5,000 weekly users on the website, and it's growing. I launched the Android app, which also sits on the same infrastructure. Launched that 3 days ago. So we're also looking to grow that. You know, we plan to, you know, to launch the platform to 1 million users plus. You know, our team is growing. There's not just one developer anymore. It's not just me in my bedroom coding. There are other people who are contributing and adding code to the system. So that very quickly starts introducing newer challenges and allows us now to grow our infrastructure even more while still sitting on Firebase. And one of the features that we've implemented, there's many things that we've implemented, but one of the things that I've implemented was switching over from Firebase hosting and implementing Cloud Run. So no longer use Firebase hosting. I don't deploy there anymore. We package our code, push it to GitHub, and it goes into Cloud Run, and it's pushed to the staging environment. Why this was important was in the beginning I was one developer. I could afford to push there and send it to a couple hundred people, but now that there's thousands of users and very soon hundreds of thousands and even millions, I can't just push a feature directly to 10,000 people whenever I update it, right? We need something like a canary deployments where everything is deployed to 0% and then we slowly roll it out to 15%. If it's working, we go to full rollout. If it's not, we can come back down. And as you can see, we now have that staging environment and production. And again, keep your mindset on, this is a guy who was not coding before. We now have that little CI/CD for the remote developers and to kind of automate things because we're deploying many things. We're deploying Android apps. Those are also automated as well. So it's very necessary, especially in this environment that we're in where we can't really meet up as teams as much. Another interesting one is cloud workflows. As I mentioned earlier, we have 20, 30, 40 cloud functions all running at the same time. Sometimes it's not even me who's deploying these cloud functions. So it can become a mess very quickly in terms of how to organize these things. So I found out about cloud workflows, and it's a very nice way of organizing those functions or those processes that are part of these workflows that have a series of steps and they're related together. And an example is monthly billing. When people, every month we have to go and bill our users. So once we bill them, we have to do some accounting, email the user receipts, do some other metric stuff, and then return something. We can nicely write, we can describe that in a YAML file, and from there, this workflow can then go individually and call these services and pass that data down. And we can actually design the flow of information, and you can visually see on the right here what that looks like. And that's very helpful, again, because what we want is an efficient way of delivering our service, whilst also making sure that our infrastructure is not getting too sophisticated and too complicated to manage, because then that takes away attention from what we are trying to achieve. So this is our current infrastructure. It's we have our client apps. All our websites are now on Cloud Run, except for one or two that we're trying, we're running experiments on. And then from those Cloud Run services, we access our Firebase. We no longer have Firebase hosting here. We still access storage, functions, database, and authentication. We also use push notifications and analytics. But that's where we're at right now. As you can see, we push our code to Git. It goes to Cloud Build, and then it's pushed into as a container to Cloud Run. Our workflows, as you can see, are invoked, on a periodical basis. They're scheduled, so that's very nice. So essentially, Firebase, for me, when I get asked what it means, it's something that has actually allowed me to express what I wanted to express all this time. I didn't know the language, I didn't know how to speak it, but I was able to come up with an idea, build it in my bedroom, start small, and get big. Now this can go anywhere. Now we can hire developers, we can get some money, and we can do some very sophisticated stuff. So for me, I'm very excited about what we've been able to do with Firebase, and I encourage people who have ideas, who are not too technical, or even if you are technical and you're looking for a simple way of pushing your web applications onto the net. This might be something you might want to consider. As far as my relationship is concerned with Firebase, I would say it's a happy marriage. I'm optimistic about the future. Streamer wants to grow big. We want to be the Spotify of Africa. I hope this talk has been very helpful for someone, and I'm welcome to questions. Thank you very much.
Yeah,
so much,
Daniel, you want to thank our guests today?
Yeah, I think both of them could thank you, but you are the ones to judge. I know Kudz from before. This is third time I'm listening to his talk, so I hope it enlightened you, showed the true serverless mindset. And so,
if I will take away from this talk something, and the most of it will be as an inspiration, which you just brought with your SaaS. It's a SaaS model what you have built there. Amazing. And my first question would be you said already what would be your traffic right now? I think you said something about thousands of users, right? Okay, and what is your monthly bill which you are paying for your Firebase or Google Cloud services? Just to know, to learn the proportion.
Right now, very honestly, I pay maximum $20.
Wow.
It's ridiculous, and we're only at 5,000. So there's been a bit of misuse where sometimes I've left some service running, and something has happened. But that's my own user errors. But in terms of our recurring bill, sometimes it's even less. So I'm not paying anything. $20. I don't know. Is not much. Yeah.
That's
and there's that free tier as well. Yeah. So you have about 1 million invocations on Cloud Run, 1 million invocations on hosting, on the database, 1 million requests. So, by the time you get to thousands, you're still operating in a way in that free tier. So we're in a good place, I'd say.
That's amazing. That's just peanuts what you're paying there for the whole service. Great. Let's see if we have other questions. If you will, anyone, if you like, you can unmute yourself and ask the question directly, or you can post it into the chat.
I do have a question, if I may.
Yeah,
Henry,
sure.
you're welcome. Good to see you.
Likewise, Daniel. Thank you very much for organizing this. Great project, by the way. I mean, I'm always sort of interested in what people are doing on the music side. Having been involved in music and probably well over a decade. So my question actually is on the business side, simply because, there was no mention, and maybe I missed it, but I don't remember hearing it. There were no mentions of any kind of some of the royalties that need to be paid. Simply because once you start to scale, like, fun little projects like that for personal use, totally cool. The minute you step out of personal, there are royalties that need to be paid. And that's essentially how the big portals that we know sort of operate, because these things have to be sort of doled out. So what is your situation with that regard?
In terms of royalties, that's the biggest thing that we're trying to solve. So we're trying to solve two things. One is that access. There's no access. I think it's only last week Spotify and I'm not sure about Apple Music. They announced that they will start to look at the African market and maybe start to roll out. But whatever that means, I don't know. But that means that Spotify, Apple Music, and Deezer, the three big ones, are not available to people on the ground. So what we're bringing is access. We've created a platform where there's all this music that we've aggregated. We're saying, hey, you can access it. But we're also going to the user and saying, you can access it, but you need to pay a fair amount. We pay $10 for Spotify in Canada. $10 in Zimbabwe is 10% of someone's monthly wage. They get paid $100 a month. So when you ask people to pay $10, it doesn't work. So we've come up with a royalty, with an amount where we can negotiate with the artists, and we've said, hey, let's start at $2. Let's see how that works out. Right now, we're giving out 98% royalty. It's on the website as a way of promoting the service. So we're essentially giving away all the royalties, and then we take money from ads. That's the money that we take for admin expenses. As the economy starts to get better, we can start to pay out more royalties. But what we're saying is this: people have been listening to music and they will get it for free. But we're saying, look, let's negotiate here, artists and users, and be able to come up with a price, because that's what it's all about. Because if we can't agree, users will always have music. If you want a song by Justin Bieber, you're going to get that song. But we're saying, no, pay him something. And the artists at this point are okay with that model, at least the ones that we've worked with, because of the whole, even the COVID thing has emphasized the importance of what we're doing. A lot of people are not working from home in Africa. Artists can't do performances because you can't have large crowds. So it's these digital platforms that then come in now, and we can now go to and say, hey, just release your music and people can pay you from home. And now they're seeing the importance of it. Before that, they didn't really care because they could go and perform and they make their money from performances. They can go international, but you cannot do that right now. So I hope that answers the question.
It actually kind of didn't, but I'll tell you why, because I think, I'm also going to ask actually for extra detail. So I'm assuming every single artist that you have on this site, this streaming site, is, I'm assuming, independent, with absolutely no arrangements outside of themselves. Is that correct?
Record labels don't exist back home. This is that infrastructure. I know it's hard to believe, but there's no infrastructure like that, where most people are independent. It's only when you become popular, when you have that formality where you can someone have paying for you. It's very informal economy. So that's what we're trying to solve. But I would really be happy to speak with you after, though.
No, totally
I'm
cool. I
totally
mean, like, I
open to
understand the
answer
whole
that,
thing
and
because
yeah.
I come from the music commerce end of town.
Yeah.
So
I'm a music player myself. I play keyboard, so yeah.
Totally cool. And
Yeah.
I did, like I said, a decade and plus at major labels. So I'm trying to understand, where, like, I'm assuming again that these are all independent artists. They have no publishing deals. They have no deals outside of like their own ecosystem themselves. So they could do like these literal hand-to-hand, sort of, handshake agreements with you and your portal. And that's what I'm assuming then.
I love where this is going. You guys are both local. I'll introduce you. So you can.
It's all good. It's all good. You know what I mean? So
13 more minutes. Any other technical questions?
yeah, please, by all means.
Like anybody else? So I had a billing question as well. So Karen asked that on the topic of Firebase, I posted in the chat, one of the meetups will be horror bills related to Firebase. That will be, I think, next month. So you can register there. So it's sometimes people make mistakes, and that will educate you when you go happily ever after. You don't make mistakes like the guy that's going to be my guest next month. So
yeah, cool. By the way, I have just posted into the chat the feedback form, and it's the same form where you can apply for the participation in this raffle, which we will run in a few minutes. So it's very small. It's just like how you liked or disliked this session and what you would improve there. And you have to leave your email and your name. We will do anything else from it other than just running this raffle at the end. And that's pretty much it. Just use this link and we can continue with the questions.
And also, like Kudz, while people are getting encouraged to ask you, I hope next time you visit, you'll be subsidiary of Spotify.
Yes, that would be the best outcome. So I look forward to that.
It's the same platform. It's Google, so
Yeah.
it's going to be easy to absorb you.
And we love what they're doing, There's not one burger shop in the world. There is not one supermarket in the world. But if you look at it from a macro point of view, everybody's adding something, to make it a bit easier for us to access some of these things. I see there's a question about at what point do you decide to move from Firebase hosting to Cloud Run? Again, I'm not a very architect type person. For me, I add things as per needs. So I noticed that once we had that basic infrastructure going, we had maybe a couple hundred people able to successfully go on the site and listen to music. And you start to get to thousands of people slowly visiting as you're looking at your metrics. You start to say, okay, I have this feature that I want to add. What is the cost of me pushing that feature and not working? And am I happy to take that risk? And you start to look at other issues of, so I started looking at solutions once again of how I could mitigate that. And some of these things I run into them asking friends who are in the field already, and you get ideas, you get recommended some of these things. And now I know what to search for. So I bumped into Cloud Run. It seemed like it made sense. I wanted to be able to have that staging environment. It's very important because I have so many features lined up, but I can't implement them all at the same time. And if I'm implementing those things, I don't want them to just arrive directly to 100% of the traffic. I want to test a little bit. I want to see what's going to happen. So that's how I make my decisions. And I think maybe that's a better way of making some of these technical decisions. With some of them, you have to be preemptive, like security and all those other things. But in terms of building out from Firebase, you have to look at your own infrastructure and see that is it necessary. The last thing you need is a necessary technology. And the goal is to create a service. If Firebase does the job on its own, then let it run on its own. But if we need something else, then we're going to slowly add that, and it'll slowly become sophisticated, but not because Cloud Run is a new product or AWS is the most popular cloud platform. Yeah.
Awesome. Thank you so much for being with us. Danny, did we deliver the way C2C expected?
Yeah, well, I just want to echo the thanks to both of our speakers. That was really great. Yeah, you delivered exactly kind of what we expected. And this is the type of thing that C2C wants to do, both partnering with groups like this for sessions like this. You know, we have a lot of sessions similar, deep dive presentations or more kind of shorter sessions that are more interactive talks that begin with a customer sharing their story. So if you're interested in Google Cloud and you want more stuff like this, we're looking and welcoming everyone to join our community. And so I'll drop some things into the chat right now. For those of you who maybe missed my spiel before, we're going to be raffling off one hoodie via the raffle of all of the sponsored stuff here, but we're also co-sponsoring this because we want everyone to come be a part of our independent Google Cloud community as well. So there will be 4 more that if you sign up on our community, we're going to raffle from there to ship you a hoodie and perhaps some other C2C swag as well. So please sign up. There's no cost. More events like these. There's our new community platform for online discussions, and we'll be adding articles and videos and things like that for you to be able to access. But thanks again to all of the speakers for that was really the real reason for the session, and the best part of the session is that expertise. So we appreciate it.
Sorry, I added my LinkedIn in the chat just in case there are people who might want to continue discussing. I'm very happy to do that. Please feel free to discuss or reach me. Thanks.
Can we talk a little bit about the prices? I will drop in the chat for everybody the code for O'Reilly. Everybody can apply for 1 month of full library access. And also, I will drop in the chat Dan's code for everyone to take advantage of. And I will hand it over to Karen for the raffle.
Okay. Thank you, Linda. So,
I have only one question. Who will keep the names? Who will write down the names? Can you save the names when you raffle them? Copy and paste?
I think it will be recorded anyways. It will be on the recording, and we will figure out later. But I will try to. Daniel, if you can just note the names of the winners.
Okay.
Would be really great. Yeah. So to the prizes, we have a special training course, I guess. It's a practice exam for the Google Cloud Associate Cloud Engineer by Dan Sullivan, by our first speaker today. And Dan has many like other courses and books. He just has he have a lot of like amazing content. You can check it out if you don't know what he's doing. And Linda, how is it going to work? You are going to post this link so that everyone can make use of it, right?
Yeah, I'm writing now in the chat, and I will paste it for everybody.
Cool. Probably we will also insert it in the follow-up kind of communication, right? Or do you want to share it only in the chat?
Oh, when we share all the resources in the follow-up email, we can include it also to that and this. Okay.
That helps really a lot, because you will receive it in your inbox with all this summary of the event. Great. Yeah. So C2C is an independent cloud, Google Cloud community is offering 5 hoodies. 4 of them you will be raffled off once you join them. And Danny, we're posting the links, but I think we will have it. I see it right now. Elias is posting it into the chat. We will have it again in today's or tomorrow's follow-up communication, so you have a chance to join their community. And they will raffle off 4 of the hoodies. One of the hoodies we will raffle off right now. O'Reilly 5 books will be raffled off right now, and 1 month of free access will be given via the code, I guess, Linda, to everyone also, or is it only one person, or how it works?
I already dropped in the chat the link for everybody to join O'Reilly 30 days full access to the library. There is a note, if you already joined with an email address in the past, this offer from one of us, you might not be able to get it. But if you try with another email, of course. So if it doesn't work, maybe that's why, if you use it in the past only.
Okay. But we will raffle off 5 books in this session, right? Okay.
Yeah.
Okay, and we have 4 more certification trainings for Google Cloud. You can choose it's either AC, Associate Cloud Engineer, or PC Professional Cloud Engineer, something like this.
Yes, from ROI training, yeah.
Cool, cool. Yeah, and 3 more software licenses, each for 1 year. It's worth of hundreds of dollars each, where you will have access to any of the JetBrains IDE. And if you're a developer, you should know that JetBrains IDE are pretty much like state of the art. They use pretty much like even some partially artificial intelligence to complete your code and check for mistakes and stuff like this. Okay, yeah, this is your last chance to submit the form. I'm just posting right now the form again. If you missed something, just use this a couple of seconds to fill out the form, and I will just simply go and grab your names there. We have 31 responses. Let's take everyone, and then we will go to our amazing wheel of names. Here you go. You should see somewhere there your name if you apply and submitted the form. For our first prize will be the C2C independent Google Cloud Community hoodie. Let's go for a spin. It will be without sound, so usually this app has some sound, but I never manage to make it work with my computers. And the winner is Atul. Cool. Congratulations, Atul. What else we got? We have 5 books, O'Reilly books. Let's go, or should we start with a different one, with courses? What do you think, Linda?
Oh, you can go for a book. Let's do one C2C, one or
Daniel will
and
go
one,
crazy. Daniel will go crazy, you know, writing down.
Yeah, I'm writing down. I'm trying to writing down, so
okay,
I will try to keep an eye. Okay.
I'm going to send a recording. It was your idea to give so many gifts. I give one gift, that's it.
Let's go for like with one sponsor at once, so that we just don't make our work too complicated. Let's go for this 4 courses. What's the company again, Linda?
ROI training.
Yeah. Okay, so let's go for the first training. Oh, congratulations to Carol. Let's go for the second one. Hey, it was very close, but it was Sati. Okay, congratulations to Sati. The third one. Very clean, it's Asmi. Let's go for the fourth one. Congratulations, Alberto. You asked really cool questions during the session. And now we can distribute 5 books from O'Reilly. Let's go for the first book. It's Sagar. Congratulations, Sagar. Let's go for the second book. It's Firman. Congratulations to Firman. Let's go for the third book. And congratulations to Omer.
You're a lucky one. You just got the book on my meetup a week ago.
That's cool. You cannot have enough of books, right?
Yeah. And they're going to Turkey, just to let you know.
Okay, and we have Ahmed for the it's fourth book, right? Who is noting?
I recorded.
Okay, let's go for the last book. It's Ruhan. Congratulations to Ruhan. So we've raffled off all the books from O'Reilly, and we have 3 software licenses left. If you will get a license, you are not a developer, find a developer in your circle, present, like give it to them. They will be like super happy. Let's go for the first license. It's Suman. Congratulations to Suman. Let's go for the second one. Hey, it's Hasmik. Very clean win. Congratulations to Hasmik. Let's go for the third one, the last one. It's very clean win, Abhinav. Congratulations. Linda, Daniel, do we have anything left?
I guess that's it. We are a little bit over the time. I want to thank you. So we did work together. So I like we're funneling everybody to C2C community, but there is importance also of your community, like how Karen, Linda, and I met. There is a huge cloud-to-cloud community. So if you're new to cloud, you don't know which way to go. Karen's group is cloud agnostic. It can teach you any cloud. So start there, and then triage. Like when you mature to architect level solutioning, you see the types of the things I like. Then you can learn more from Serverless Toronto user group. We also started offering consulting work for fee to your bosses. And then when you know you're committed to Google, then we're going to be peer-peer to talk to with the C2C group. So if you're new,
let's congratulate all our winners, please, before. Yes. Congratulations, all the winners.
Yes.
Yeah.
And that's it basically. And I think the knowledge we shared was a good gift enough. Like there was no need for all the books, but thank you, Linda, for finding the sponsors.
Thank you. Even Karen, everybody finds some sponsors.
Let's let Danny have a closing word here with his C2C community who actually originated this whole event.
Yeah, you know, Daniel put it really well, right? So it's really great that there's these other groups that are dealing with all of the clouds. If you decide to specialize in Google Cloud, if you work at all with Google Cloud and you want to connect with others who can help you, we want to be that place 24/7, 365 where you can ask questions and have conversations. And then to do more events like this with great speakers sharing their expertise. Our focus is going to be on customer stories and use cases as well as keeping you up to date. So it should be a good place to find inspiration as well as to expand your network. So invite everybody to come join us. I've seen a lot of you have signed up already, so thanks to that. And appreciate everybody's time, especially those who presented today and our organizers for putting this together. So looking forward to shipping out some hoodies next week.
Thank you for inspiring us.
Thank you, everybody. Give us a day or two to contact you by email with your codes and everything. We have to retrieve. I tried to write all the names, but we will need the emails and things like this. And I will have to rewatch the video to get the right names on to make sure that I give the right price to the right person. So definitely in a day or two, you will receive the email with your prizes. And thank you, everybody, for joining us.
Thank you. Stay safe and be kind to one another. That's the most important thing, sharing and caring. Ciao.
Thank you, everyone. Take care. Bye-bye.
Thank you.
Bye-bye.